Starting. All attendees are in listen-only mode.
Hello, everyone. This is Chris Congleton. I'd like to thank everybody for coming today to the Design Across FEMA's Floodways webinar series. It's actually not a series. It might be, but right now it's just a single. We'd like to thank Ronald Mader for presenting today. He's taken his time and his energy to get the information we need to better, I guess, assess FEMA floodways when we're dealing with projects. Before we start, I'd like to go through a couple of things. If you want to go back and look at previous webinars that we've done through KYTC, you can actually go to the software and support page, or it might be a little easier to go to the highway design page. And if you look at the red arrow here, you can actually go to a resources link, which will take you to the software and support page. You can actually view all the webinars we've done in the past. It's a lot of information there to have to go through, but it's always nice to be able to go back and look at what we've done before if you're having any problems with some of the subjects that we've discussed. If anybody has any questions about MicroStation, En-ROADS, project-wise, you can actually contact us at KYTC CAD support at ky.gov. So far, I don't think there's any answers we haven't been able to answer. Maybe one that I can think of, but I'm pretty sure it even got answered. So contact us there, and we actually have a team here that can get a hold of you and answer any questions you may have on those applications. A couple of reminders. To get professional development hours, you have to be present for the entire webinar. We actually have telemetry through GoToWebinar, which allows us to know if you're here the entire time. It tells us when you came in to the webinar and when you leave the webinar. And because of liability reasons, if you get audited and somebody comes and asks me how much time you spent in the webinar, I have to, by law, tell them the truth. So I won't award a certificate to anybody if they haven't actually attended the entire webinar. I'm sorry for that. Don't kill the messenger. I'm just trying to do my best to get you guys the professional development hours, but you all have to show up. One of the things you can do is if you have a computer in a conference room or something like that, you could actually watch it as a group to get your professional development hours. However, it was highly recommended that you use a sign-in sheet so that you have evidence that you attended in case you get audited for your professional development hours. Also, we have a survey at the end of our at the end of our presentation today. Please don't forget to take that survey. It's actually invaluable to us to let us know what you're learning, if you enjoy the webinar, and any suggestions you might have about our webinars. If you can, whenever the webinar ends, give it just a little bit of time to load up the survey, because it takes sometimes as much as a minute or two to actually load up the survey. So please give it a little bit of time and answer those surveys for us so that we can get some of that feedback from you guys. If anybody's feeling adventurous, we can actually now have the ability to set up a microphone. We've had it for some time. We've only had one person actually do it a long time ago, but if you want to set up a microphone, you can do that. And during our question and answer session at the end of the webinar, if you raise your hand, which you can do through your GoToWebinar panel, that actually pops up your menu panel. You can actually click on a little hand, and it'll raise your hand, and I can call on you and actually open up the microphone if you have a microphone available. But you have to set one up. That way you don't have to type if you have difficulty typing like many of us do, where you hunt and peck. So let's go ahead and do a couple of poll questions before we start our webinar. And our first one is, do you find FEMA floodways challenging to deal with on a project? So we'll give a little bit of time here. I know personally I do on the instances where I've had to deal with them. Hopefully get up here to around 90% people voting. and we'll shut her down and look at the results. All right, we're close here. And it looks like 27% of you actually find FEMA floodways challenging. 60% sometimes. Nobody thinks that they're not a challenge, which is great. And a few of you have never done them, which you feel lucky. That's a good thing. I would say probably most people, would sometimes find them challenging. That the instances where I've had to deal with them, they were fairly challenging. Okay, let's go on to our next poll. Thank you for your feedback there. The next one is how often does your work involve dealing with floodway? This is a question of frequency. I'd probably be up more on a rarely of this one. I don't have to deal with them too much, luckily. See if we can get up there around 85, 90% before we show the results. Okay, we're about there. So it looks like about 17% actually deal with them on a once a month basis. So hopefully this webinar will actually help you guys out, you guys and gals, I should say. 41% of you about once a year or more. I'd say that's probably where I land, is a once a year or more kind of a thing, and 40 is rarely, which is good, and then 1% never. Okay, so if you've never dealt with it, this will certainly help you, unless you already know everything. So with that involved, let's go on to the presentation. Let's see if Ron's ready. Ron, you ready, bud?
Yes, I think I am.
Okay, I'm going to hand it off to you, and you can take the reins. So Ron has a lot of experience in this stuff, and Ron, I want to thank you for taking your time to kind of help us out on how to deal with these things on projects.
Okay, I think I'm waiting for my screen to show up. So am I there? I think I'm good.
Yeah, you're good.
Okay. All right. Good morning, everyone. Thanks for showing up at the webinar, so to speak. This morning, we're going to, as you know already, talk about FEMA and floodways and how to design across them. I really appreciate the questions because you verify what I assumed, and that is most people deal with these every once in a while, and because of that, when you deal with them, you kind of have to relearn what it is maybe you had discovered a while back, and if you're like me, you kind of forget some of those details of how you handle the floodway, and then a year later you go through it again, and okay, how did we do it? And it seems kind of confusing. So hopefully this webinar will be able to document some of the things that everybody needs to consider as you design across floodways. Today we're going to talk about designing across them. We're going to define the floodway, since we have so many people that don't have that much knowledge about this area. I'm going to define it. We'll discuss a no-rise, and we'll discuss a letter of map revision. Then I'm going to go through an example that demonstrates some of the benefits you can get when you understand the process that goes into developing the floodway and how we are supposed to deal with floodways. There's a great benefit when you really can understand that a little bit better. The target audience I have is probably going to be people that know a little bit less about FEMA and FEMA floodways. So I'll be shooting more for that audience. So I know some of you, I think my whole department is listening in, and they already know a lot about all this. Obviously, I've not given them enough work, so I'll deal with that after this. Okay, let's jump in with the floodways. First, we're going to talk about the concept of a floodway and what is a floodway. This is a cross section, and when it comes to a cross section, one of the main things that we consider in the cross section is the spread of a 100-year storm. So most everyone hopefully is familiar with when it comes to dealing with the FEMA floodway, the storm event that we're most interested in, or that we are interested in, is the 100-year flood event. So just assume this cross section shows the spread of a 100-year flood event across this cross section. I'm going to give you the definition that we use for a floodway. A floodway is the river channel, so in between the banks of the channel, and any adjacent land that we must reserve in order to discharge that base flood, which for our purposes is the 100-year flood. So we need to reserve that in order to discharge the 100-year flood without increasing the elevation of the floodwaters more than some designated height. And you probably already know that designated height for the state of Kentucky is 1 foot. So for this type of spread of a 100-year storm, it would look like this. We would encroach on the sides, on each side of the channel. We would push the floodwaters together until the elevation of that 100-year storm is right at 1 foot higher than the 100-year storm event. So that is the definition. It is the floodway is the river channel and any adjacent land that we must reserve in order to discharge the base flood without increasing the floodwaters more than a designated height. All right, when it comes to modeling a floodway, HEC-RAS follows an encroachment methods analysis. And what that means is the software starts constricting the flow on each side of the channel, and it systematically starts pushing that water together, and it tries to balance how much flow is being lost on each side until it gets to the point where the elevation of that encroachment approaches 1 foot. And then when it comes to the 1 foot, where does the 1 foot come from? The 1 foot is the maximum allowable surcharge that FEMA will allow any state in the country to use. So state of Kentucky, we use the maximum for that. So that's just something to be aware of. The other states, they do use a different amount. Some states do. All right. Now, with respect to the location of those floodway limits, I just want to make sure, yeah, there we are. With respect to the location of the floodway limits, FEMA does not have rigid guidelines for how we go about developing the floodway. And therefore, we do have some latitude about how we can develop this floodway. So where that encroachment comes to, we can actually maybe shift it left or right, depending on how you're looking at your channel. But you can shift it, and in shifting it, you can have some benefit. Usually it has to do, let's say that there is a proposed development that's coming, on one side of the channel, and we would like, for the benefit of progress, for that floodway to be shifted to the other side. Well, that is a reason enough for FEMA to consider allowing that floodway to move to one side of the channel. Now, when it comes to getting these things approved, of course, FEMA has to approve it, but the local community and the floodplain manager have to be in agreement with it too. So if, for example, you're on the wrong side of the channel here, you would have a voice in being able to say whether you agree with this or not. So it is a process that we can go through, but the point for us is where that floodway is, there is some ability to manage that if we work with FEMA. All right. Again, I stated earlier, when it comes to the FEMA floodway standard, we use the 1 foot maximum for that surcharge. The state of Indiana, if you've ever had to deal with them, their maximum allowable surcharge is 1/10 of a foot. Actually, it's 1400s, but it's 1/10 of a foot. So you can understand that the width of their floodways are much wider since they cannot encroach as much. And one of the differences dealing with them, how they handle their floodway is so much different than how we handle our floodway. When we create a floodway, the how you handle our floodway is stay out of it. That's just the point. You just stay out of the floodway. If you get in there, now there's going to be some really significant things are going to happen. So, but we stay out of the floodway. There, they can get in the floodway, and then they deal with the impacts that creates by having to buy easements. So anyway, dealing with the state of Indiana, they deal with things a lot differently than we do. All right, floodways are only found in special flood hazard areas, and those are called Zone AE. Don't really need to remember this or memorize this, but if you're used to seeing on a GIS or some type of mapping, you will see that the area where a floodway, there's a Zone AE. It's usually listed with that map. And that's just the area where we have done a detailed study of that area. And that usually involves either a HEC-RAS, or if it's an older model that of somewhere that hasn't been updated lately, it could be a HEC-2. There's a few other models that have been used. But there's been an in-depth hydraulic analysis of the area, and FEMA has been brought into play, and there's a floodplain manager, there's a community that makes use of it. So this that's where you're going to find floodways, in a Zone AE. Also, with respect to that, there are going to be base flood elevations developed in a Zone AE. And those base flood elevations are used by the local community, the floodplain coordinator, by the for the purposes of really getting flood insurance. If you're in the floodplain, you need to go about getting flood insurance, and this tells you whether you have to buy the expensive flood insurance, or if you're outside of that floodplain, then you fortunately don't have to buy this very expensive insurance. There are requirements that go into managing this floodplain. One of the things, you know, just the truth of the matter is you know, I've only been with the transportation about 9 years, and transportation doesn't have a history of always dealing with FEMA appropriately. And one of the impacts of doing this is it can be a negative impact on people's ability to get flood insurance. If we don't handle the FEMA floodways and their floodplains correctly, then some people can be forced to buy some expensive insurance. And it turns out it's something that we can handle. And one of the reasons why I think a lot of people are seeing more CLOMARs is because it is something that we can deal with correctly and well. And I think we are doing that. All right, Zone AE does not always have a floodway located within it. So if you see a Zone AE and there's not a floodway, that's not uncommon. All right, when it comes to our projects, if we have a project that involves a floodway, what are the options in front of us? Well, if we can make the structure span the floodway, and we can have the low chord above that floodway elevation, then no floodway assessment. So this really, option number one is we're going to span it. We're going to stay out of the floodway, and then everything's good. We don't have to really do anything else. Option number two, if the proposed structure, it encroaches in the floodway limits, then we can analyze it. Let's say it's just one pier. Then we can analyze it and see if we can get a no-rise, that we have really not changed the hydraulic model enough for there to be any change in the model. So the next thing we'll try to do is, if we can't get a span, we can't span it, which usually that's an economic reason for not being able to span it, then we encroach and we see if we can get a no-rise. And again, we don't have, we just have to develop a letter that states that we have the no-rise. Well, if we can't do either one of those two, we encroach in the floodway limits, a no-rise cannot be achieved, then we have to get a letter of map revision. And the first thing you do in getting a letter of map revision is we have to get conditional approval from FEMA. Therefore, that's where the CLOMAR comes from. We have to get conditional approval that what we're going to do is acceptable to them. All right, the first thing that we're going to talk about is if we have a project across a floodway and we plan to span the floodway. Well, this is kind of the simplest one, and I think this is where I see transportation always kind of go. They want to design the bridge not to encroach in the floodway zone, and they want to make sure that the low chord does not hit the 100-year flood elevation. So that's going to be our number one approach, and hopefully we can make that happen without spending too much of the funds. All right, so that was easy to cover. Let's go to number two. Let's say that we cannot span the floodway. It's just maybe too expensive usually, and now we have some encroachment. So we're going to try to see if we can get a no-rise out of this situation. Okay, so if the structure encroaches on either side of the floodway zone, or if the low chord encroaches into the floodway, then we have to see if we can make the change of that flood elevation caused by this structure that we're proposing. If it can be less than a tenth of a foot change in the hydraulics for that bridge, then we can achieve a no-rise. Where does a tenth of a foot, really, I tell people 400s, because if you round off to the tenth, so if it gets to 500s, then that's a tenth of a foot. So you can, if you have a change up to 400s, then that's okay. But whenever it gets to 500s, now that's a tenth of a foot, and that's not okay. All right, there is a little bit of confusion, not confusion, that's probably not the best word, but there is some dilemma that we have, at least in central office, when it comes to dealing with the no-rise, mainly because we have some different interpretations about how what constitutes a no-rise and how it should be analyzed. So let me talk about that just a little bit, and you don't have to totally understand this, but at least I can introduce it to you. If a project element encroaches but has no effect on the flood water surface elevation, such as piers, the project may be considered consistent with the no-rise. And so according to the drainage manual, which is what this is quoting, this is justifiable if the hydraulic conditions can be improved so that no water surface elevation increase or no change in lateral limits of the floodway or floodplain is reflected in the computer printout, that's a little old language, for the new conditions. Now, the issue that we have with this is this says the hydraulic conditions cannot change for both the floodway, it says or, for the floodway or the floodplain. And that is a little bit problematic. When you go to FEMA's language, FEMA has the same language, and that's where the previous writer of the drainage manual got that from. The FEMA no-rise certification guidance language states that no impact or no changes to the base flood elevations, or regulatory floodway elevations or regulatory floodway widths. So it uses the same language. I clicked too fast. It uses same language. Let me previous. There we go. So what this seems to imply is that both floodplain and floodway elevations cannot change. All right. So let's consider the floodway below. I'm going to wait till your screen catches up. So I'm showing a different screen, but my audience view shows. So does this show the floodway, Chris? If you're still there.
I'm actually seeing, like, you're
No
still seeing
rise?
your presentation with where you've
I should
circled
hit
floodway elevations and base flood elevations.
Yeah, how do I get it to move to the next slide?
If you actually, it should be able to move to the next slide when you actually move to the next slide on your presentation.
I did.
There it went. It just moved.
Oh, there we go. Thank you very much. Sorry to involve you.
No
All
problem.
right. So let's consider the floodway. Sorry for the blip there. So let's consider the floodway here. So if we're going to design across the floodway, what's the number one thing we're going to try to do? We're going to try to span this floodway. So let's say that we do that. So we put an embankment on the left side and the right side, and we put a bridge across it, and we make sure the low chord of the bridge is above the floodway elevation. No action is required by us. Okay, so now we have the same bridge, but we had to drop a couple of piers in that. Well, now we need to achieve a no rise. All right. Now, according to the drainage manual and according to FEMA's, if you read FEMA's language also, it says that the no rise has to be achieved for both the floodway and for the floodplain. Now, doing it for the floodway doesn't seem to be probably that difficult. It's like, okay, that's not that much area, especially if we did a little bit of work on one side, we could probably get a no rise maybe pretty easily for that. But if you look at the floodplain, so the floodplain, our embankment has blocked a significant amount of the water flowing in the floodplain. It is virtually impossible for us to get a no rise if we try to get it for the floodplain. So when a floodplain is included in getting a no rise, that pretty much knocks us out. AASHTO, though, it states that a no rise is required for the floodway and not the floodplain. It does not specify the floodplain, and this conforms with the Federal Highways Memorandum of Understanding with FEMA. And when you go to the AASHTO Drainage Manual, it says that no map revisions are necessary under the following conditions. All constructions outside the floodway boundary, the bridge low chords are above the regulatory floodway elevation, and construction within the floodway, for example, piers, but the base flood elevations are the same or lower due to compensatory improvements. But everything is with respect to the floodway. It has nothing to do with the floodplain. So that's a little bit of, we kind of handle things a little bit differently. So how are we going to handle that? Generally, when it comes to a no rise, we handle it on a case-by-case basis. Often, a no rise is not attainable and the issue is moot. But if we ever got in a situation where a significant capital cost to the transportation cabinet is due to this issue, then we probably would decide to comply with our memorandum of understanding, which is just the floodway. And then we've never had to do that yet, but I just thought if we get to that, if you notice that we kind of scratch our heads and get a little bit, or go a little bit carefully, it's only because we happen to go very carefully. All right, how do we determine if a no rise is achieved? Well, what we use is we use HEC-RAS to analyze the hydraulics of the proposed structure, and that includes the approaches and any other pertinent hydraulic modifications that we need. And I would like, this is the only time I'm really drilling down a little bit, but I'd like for you to understand a few of the terms that we deal with when this no rise comes up. Some of the terms are, we'll talk about an effective model, a duplicate effective model, a corrected effective model, existing conditions model, and a proposed model. Again, you don't have to really understand all of these models. The one that I might have you try to maybe remember a little bit is what the effective model is. The effective model is the model that is used by the city, the county, the community, and by FEMA, where the published values and the mapping comes from. So whatever's behind that mapping, whatever's behind those published elevations that everyone's using, that is called the effective model. Now, if that model was developed last year, then, well, that's easy to understand. That's obviously the newest model. But if that model was developed in the 1980s, it's a HEC2 model. That model is called the effective model. And it's usually the HEC2 type models back in the 80s, many years ago, that create the need for having to go about it like this. So what happens is, after you have your effective model, let's say it was a model, a HEC 2 model from the 80s, then the engineer, if we're having to come up with a no-rise, well, we need to have that model on our computer. So we try to duplicate that model on our computer, therefore a duplicate effective model. And so we get that HEC 2 or whatever model is, we try to get it running on our computer, and we cannot make any changes to certain parameters, whether it's encroachments, the expansion, contraction coefficients, the topography, N values. None of those can be changed. We're just trying to get the model to run properly on our machine. There should be no differences between the results of the effective model and the duplicate effective model that's now running on our machine. The only time that can be that's different is when we have the HEC 2 and we're converting it to HEC RAS. There is some differences that can be accepted by FEMA. FEMA does have to weigh in and agree with those differences. And sometimes we just get a model that, as everybody knows, that if you've dealt with HEC RAS, it just doesn't act right. And so where we have some significant differences and discrepancies, we can go to FEMA, and if we can get their agreement, they can agree that there is a difference here, and they can agree that we can go on with that model that's not exactly the same as the effective model. So the next thing that we do is we try to correct this model that we've now put on our machine. So it's a corrected effective model. And what we do with this model, we start fixing the errors that might be incorporated in it. And one of the errors that's most common for the older models is the topography. You know, usually the mapping we have today is superior to anything that existed many years ago. Also, some of the modeling of the bridge itself might be an error. And so at this point in time, you're trying to correct that model so that it comes up to speed with what it looks like, what it should have looked like even back in the days. This does not include any of the proposed project yet, and no man-made changes are incorporated into this model. This is just things that you know, again, should have been incorporated at the beginning. Also, if you're preparing to put in a bridge and you need a couple of extra cross sections, you know you're going to need those, this is the time to put that in. All right, now we have the existing conditions model. And that model really incorporates any of the man-made changes that have happened. So, you know, if there's been some development and a lot of fill has been incorporated that wasn't there, you know, the years but when the model was developed, well, that's a man-made change that needs to be incorporated. So that becomes more of an existing conditions. Maybe even a structure was built, a bridge on the stream, and that was not incorporated in the model because someone didn't do it when they should have. Again, this is the time to incorporate that. And again, cross sections are added as they're needed. Now, finally, we have the proposed project model, and this incorporates all the changes due to the proposed project. It also has the new structures, the bridges, the streets, the culverts, berms, grading changes, anything that needs to be incorporated for this proposed model. So, the key terms, if you understand that the effective model is the model that was used to develop what you're seeing on the maps and what you're seeing in the tables, that is the effective model. Wherever that exists, that's the one that's called the effective model. And then everything else is a little bit more intuitive, I think. All right, so now let's move to our third parameter, our third option. If we couldn't span it, and we encroached and we can't get a no-rise, so now we are stuck with getting the old Clomar, which I know we really don't want to do. Clomars cost money and they take time. So a Clomar is required in order to change the FEMA flood mapping and the elevations to incorporate our proposed roadway and bridge or culvert design. So it's required. We need to update the maps. We have to get approval from FEMA to do that. And so we have to go through this long process of handling this. The change in our flood elevation, if we're making a change, cannot be greater than a foot. If it gets greater than a foot, then we're buying everything above that. We're going to own it. Clomar is required. It requires the approval of the local floodplain coordinator, and it involves the local community. We have to deal with the local floodplain coordinators. They can vary widely as you go across the state. You know, I go to meetings with people that are floodplain coordinators. They can be engineers in, you know, Louisville and Lexington, and they can be people in rural communities that really don't know much about engineering, but they have this task in front of them, and so they depend on us a lot. But and they have a significant job because they have to keep compliance with FEMA when people are trying to develop all around them. And then let's say that we get a CLOMAR and we do the construction. Within 6 months after completion of construction, we have to do the letter of map revision. Just because we got a conditional letter of map revision, FEMA will not change the mapping. They want to make sure that it was done according to the plans, and so we're going to have to go out and survey it to see, did they do it according to plans? And that's what goes into their letter of map revision. And this all costs money, you know, a significant amount of money. All right, let's talk about additional situations that can trigger a CLOMAR. You have a hydraulic model, which is, you know, whether it's a HEC-RAS or HEC-2, and it's got significant errors. Well, you know, that's not totally uncommon, and that can by itself trigger a CLOMAR. It could be to our advantage to fix that model, and that we would need to go and do a CLOMAR so that we can have a better project in this situation. Also, if your proposed hydraulic model lowers the water surface elevation, you know, that might sound, well, that's a good thing, isn't it? Well, not if you've increased the velocity. We can cause a negative impact, and it can be unacceptable to FEMA for us to be doing that. So if we lower it, that can cause a CLOMAR. Or if there's error on the mapping. So let me show you an example of that. This is a project in Franklin County a few years ago. We have a stream that's actually, the stream ends up flowing west, but the South Elkhorn is flowing north here. It's flowing under that bridge, if you can tell the bridge. The North Elkhorn is flowing south, and it meets there on the other side of the bridge, and it turns into the Elkhorn Creek, and that water is flowing west to the city of Frankfort. And there's a bridge located in the red there, and so you see how the bridge is located with respect to these streams. So this is the image that shows the floodplain. The 100-year floodplain is in the kind of the blue, the light blue. The 500 years, that tan looking or brown looking color. So that's the 100-year floodplain. Everything looks okay. I mean, it's kind of close to the bridge. But when you look at the floodway, the hatch pattern of the floodway, that's not a good picture. You know, the floodway ought to at least be under the bridge. And this shows that it's not even grabbing the stream. So that's not really a good situation, and that can trigger us having to do a CLOMAR. So that's unfortunate because, again, that does cost us money. All right, let's say that there's an error in hydrology. We have a project near Georgetown right now that had, I wouldn't call it an error, but yeah, there really needed to be some hydrology changes for us to benefit from putting a culvert, a culvert instead of a bridge. And so we're going through a CLOMAR so that we can have a culvert there instead of a bridge. The numbers that they were using for that stream were just higher than they needed to be. And we are proving that and getting changes. There's several other situations that can trigger a CLOMAR. I would just encourage you to draw in the central office drainage engineer. They will bring things to me, our office, you know, with everybody kind of pooling together. And plus, I have good resources with FEMA that can answer some of our questions. All right, now let's get to the example that I wanted to cover. This is a project that we had in Western Kentucky, and I wanted to use it to show some of the benefits you can have when you understand the FEMA floodway a little bit better. This is the interchange of the I-24 at the Purchase Parkway, which is in green there. The project team was trying to design some improvements to this interchange a few years ago. I don't think that they finished constructing this yet. The stream in question is the Little John Creek there in the dark blue. The waters are moving toward the east, so from the left to the right. This is the image of the flood map image. And in this image, you can see in the hatch pattern, let's just start with that in the middle. The hatch pattern is the floodway. The blue-green color kind of there, I'm not sure about whether I have seeing the color exactly right, but the bluish color is the 100-year or the 1% flood. The tan color is the 500-year or the 0.2% flood. And then if you look, you'll see the black lines here. Those are actually the cross sections. There's actually a cross section right here. Those are the cross sections that exist in this. And then you can ignore really this red line. You know, there were panels back in the day, and they still, whenever we print them out, they still show these panels. But the panel on the right is this number, and then the panel on the left is this number, and this is the dividing line between these two panels. So that's all that is. So let's zoom in a little bit on this area. And again, just wanted to say that the flow is going from the left of the screen to the right of the screen. Notice the backwater here. You see backwater upstream of the Purchase Parkway. Well, that absolutely makes sense. And then you see backwater right here, so you're led to believe there's probably some type of road or some type of embankment or old railroad or something that used to be right there. So if I got rid of all the imagery behind it, this again is just the imagery. This is what we deal with. This is the mapping, and just for your benefit, you can see it's a little cleaner looking at that type of mapping. All right, so now I want you to understand how we developed this flood map, okay? So back in the 1980s is when this flood map was actually developed. In fact, I was probably the one that developed this flood map. And what we had back in the 80s is we did not have very much to go on. Fact is, when it came to our contour map, we were making use of the 1969 USGS map, and that's what we had. And when you're developing mapping for the entire county, it can be quite a challenge. This right here, I just drew on this map the three of the cross sections that were developed back in the 80s for this mapping, and those cross sections are about a half a mile long, just to give you an idea of how long those are. And you see those dots there with I guess it's kind of a purple. That is the contour lines that I'm intersecting with. So on that one, I got 2 contour points of elevation. This one I got 6, and this one I got 4. We were not given enough information to survey miles and miles of stream. In fact, I had to walk every foot of every stream that we had to do. So I had to walk it, but we did not get to survey it. And so this is the type of information that we had available for us to develop sections for this. All right. So let me, this is, see, I'm trying to make sure I got this. Okay, so this is, I've put the imagery for what we see today, and then this is the floodplain map. So just want you to see what we had to deal with and the type of mapping that we developed using what little information we had available to us in 1986. All right, so and then back then, one of the guidelines is we knew that we had limited information. We wanted to make sure, if anything, that we didn't underestimate. So when we used HEC 1, which would be called HEC HMS today, we were going to make sure we were conservative in our parameters that we're using, that we check with homeowners to make sure that what results we have were realistic for what actually occurs out in the field. Turns out you know, some even these models that look pretty rough, the results that we got were pretty decent, considering what we had to work with. Let me show you how that kind of maps up with what we have today. All right, so when it comes to cross sections, the one in yellow would be the 1986 cross section that was used. No data points available for quite a long distance, and so it's pretty much just straight lines. And even the elevation that we ended up getting was quite a bit off, it looks like. So this shows a cross section in yellow, and also it's contrasted with the actual survey elevations for the area in question. So later on, we had more of a 10-meter profile. We got better mapping with better equipment, and you see how that compares with what we had before. Certainly an improvement, but still off from what maybe the actual was. Then we got the 4-meter profile that showed even better agreement with the actual elevation. And last, in the red, you'll see the LiDAR information, almost exactly what the actual survey elevations are. So when you look at the comparison between what we had back to work with back in the 80s as opposed to what is actually out there and what we can work with today, it's drastically different. So LiDAR has really changed our ability to deal with this. So now let's return to the project. Again, we're trying to deal with this interchange. We're trying to improve it. We're going to be putting bridges across this stream. So here is the first stab at what the project team tried to do. They did what they're supposed to do. They built large bridges to span across the floodway. The floodway in this area was around, what, about 500 feet long, 600 feet long. So they had 2 bridges, 700, 750, 800-foot bridges. They're doing exactly what they're supposed to do. They are spanning the floodway. Problem is, when the numbers got up to the 6th floor, for some reason, they didn't like the numbers. You know, they just were, you know, maybe $15 or $20 million higher than they're supposed to have been. So anyway, there was pushback from this, and it was pretty obvious that we needed to do something. And actually how this came about was almost accidental. I was walking past Bill's office one day. He saw me, and they were actually looking at what you're looking at. And he drew me in, and he said, "Hey, Ron, what do you think about this?" And so they told me what county it was in, and I recognized it. And it was obvious that, you know, I think that we probably can do an improvement here. I know kind of how that thing was put together. And, you know, and there's also something else I noticed. I noticed the floodway is going straight across that embankment. Now, that doesn't make sense. Whoever it was that did that originally didn't know what they were doing. Of course, I'm talking about myself. That doesn't make any sense. So knowledge of the effective model developed in the 80s encouraged us to get a CLOMAR. And one of the things that kind of was a big red flag was the current mapping did not incorporate the culvert into the floodway. There's a culvert there, and that culvert was not incorporated into the floodway. We had no information that the floodway had ever topped. And so and the topography used for the effective model was incredibly inaccurate. And also I had personal knowledge that the hydrology, we were always very conservative. That could definitely be improved upon if we tried to make the numbers that were used back in the 80s better. So we did do a CLOMAR. We did come up with a new model, and here it is. And you can see that the floodway now goes through the culvert, which is what it has been doing. And then it comes back in and it ties back in. So this is the change that we made in the mapping. All right. So, and let me just explain a little bit why it looks kind of ugly there, how it juts down. You know, if you look at this creek, one of the things you should have noted from the very beginning, that's the straightest creek I've ever seen. Well, that comes because back in the 1800s and early 1900s, there was a huge emphasis on draining the swamp. And so we made drainage ditches straight. We put clay tile everywhere to drain. And so this is very common in places that used to be swampy for us to make straight ditches. And anyway, when it came time for them to cross this creek. And they when it came time to put in this interchange, they said, you know, we could put the culvert right in line here, but if we moved it down south just a little bit and changed the stream, that would really make things look a lot better, or it saved 40% of the culvert cost, which is what they did. And so we have an ugly looking little floodway that kind of moves in and then has to move back up and get back in the channel. And that's kind of where that came from. Well, you know, now that we have this new mapping, we could actually change the plan, the alternate, for what this interchange could look like. And so what they did wisely is the project team moved all of the structures to the right side, to the east side of the Purchase Parkway, and made all the bridges cross that very short 100-foot wide floodway. And so now the structures are about 100 foot with a 440-foot flyover. So the new bridges were significantly smaller than the original. We had two, actually it says bridges, but we actually had this down to culverts with the flyover. This shows the comparison of where we began, 4 bridges we began with, and there's 3 structures we ended with. There was also an extension of a culvert that I'm not really showing there, but the savings from being able to recognize this change and being able to do it were significant. Millions of dollars savings. So the existing floodways, they were around 700 to 800 feet wide. Preliminary plans were spanning the floodways. We updated the hydrology. We used an unsteady HEC-RAS model to develop a new floodway. The floodways were reduced to 100 feet in vicinity of the crossings. Bridges were replaced with triple box culverts. The design team did move back to bridges. They said that they preferred that at this situation, so we went along with that, of course. And finally, we provided this complete study to FEMA as a stream update. It was funny, not funny is not the right word, but one of the things is when you do a major study like this, FEMA says what they'll do is you won't have to pay the fee because you've really updated a significant part of their mapping, and they decided they wanted our money instead. So we had to pay them anyway. That wasn't very good. Anyway, but it was good that we saved all that money. Probably $7 to $10 million would be my guess. Let me talk about maybe the last thing to talk about. You know, I haven't even looked at the time. Oh, wow, I'm getting close here. The time required, pertinent, to perform a CLOMAR. All right. So let me go through that. Last thing, you're welcome to talk to me or even contact me if you have questions about this. Submitting a CLOMAR requires an in-depth submittal package. It's a HEC-RAS, GIS-based map revisions, your survey documentation, your FIS tables and your profiles, your application, your fees. And this process of putting this mapping, all this package together can take up to about 6 weeks. So all at once you discover, you know, it looks like we need a CLOMAR, then you get a project team involved. It can take about 6 weeks. It depends on the team. Some teams might take longer. You're not going to find many at all to take it shorter than that. Notifications have to be sent to impacted residents. Okay, so that's the other thing that has to happen. The people in the community are going to have to be contacted that what's going on there. And then the submittal of the CLOMAR package, it requires a response from FEMA within 90 days. So let's say that we've got 6 weeks into this, we've submitted it. Now FEMA has 90 days that they respond to us, and we sit back and wait. Every time that they have a question about this package, so if they say, you know, for some reason you didn't include your survey documentation, could you please submit that? The clock resets to 90 days. So it's very important that when we submit a package, it is complete if you want this to get out in a timely fashion. FEMA often responds within 2 to 4 weeks with very well documented CLOMARs, and that's what we've seen. They recognize CLOMARs that have been done in a very good way. They can tell it's a CLOMAR done by a company that knows what they're doing. they deal with it differently, because it turns out FEMA has their own, these reviewers, they have their own parameters that they have to work within, and it's to their benefit to move these through quickly. They benefit from that. So that's why for us, we want to make sure the Clomar package is very well done before it's submitted the first time, if we want to get this thing done in a timely fashion. Approval for well-prepared Clomar can be received within 6 to 10 weeks. So you add all that up, and it can take, we tell people it can take 6 months or more to do that. We can get it done sooner, but look at the issues that can come up with respect to the timing of getting this Clomar process. All right, I think that ends my presentation. I know I've gone through a lot. Hopefully I've covered it decently, so I might stop and see if there's any questions.
All right. Thank you, Ron. Appreciate it. We do have one question here. If anybody has any questions, please go ahead and ask them in the questions panel, and we'll answer them as best we can. We actually have one question that was asked earlier. It was a question that probably got answered, but we might want to go over it just the same. How much higher does the low chord of a bridge have to be above the floodway?
Well, that's a good question. Actually, there's some things going on with FEMA. That's good. We're going to deal with that on a case-by-case basis. So, you know, there is freeboard that we are dealing with, but you know, I probably can't give just one general answer for that. That's a little bit more complicated. So I might pass on that just for now. And whoever it is that pushed that question, they're welcome to give me a call, and I can explain to them what I'm talking about.
Okay. If they're still listening, hopefully they'll do that. Andre Johannes says it's 2 feet. I think he's wrong, but no. But at any rate, that's probably a good place to start. At any rate, another question is, how do you address floodway/floodplain encroachment on roadway widening projects?
On roadway widening?
Yeah.
Well, I guess I would have to understand exactly what they're meaning. What, you know, if there's no impact on the waterway, you see, if there's a floodway and you're not doing any construction within the floodway, then whatever you're doing there, let's say the floodway is, like in the example I had, we had the floodway, let's say right in line with the drainage structure, the culvert or the bridge. And if that's the case and we're not doing anything inside the floodway, then we don't have to do anything. But if the widening, some of the fill material is being pushed into the floodway, then that's something that needs to be looked at to see, have we made a change in the model? Or can we get a no rise with this impact that we've created, with this change that we've created inside the floodway? The point is, you don't get inside the floodway. So if their example means we are getting in the floodway a little bit, you know, we don't think it's that big of a deal, well, that's something that we need to look at hydraulically to make sure it's not a big deal.
Right. Okay. Okay, and it looks like last question, if nobody asks any more questions, basically they're asking you to repeat, where is the statement regarding the 1/10 of a foot rise as the no rise limit? Apparently this person has had struggles with folks before where the 100th, or excuse me, 100th of a foot has still been considered unacceptable.
Yeah, if you, when it comes to FEMA, you can't have a 1/10 of a foot rise. You have to have a 0 rise. Well, 0 rise, 0.0 rise. So I can't tell you exactly you know, they can contact me afterwards. I can tell them exactly where that is. But a 1/10 of a foot is, if you make a 1/10 of a foot rise, you now have an impact. If you have 0.0 feet rise, I mean, you could take it out to the millionth. That's no good. There has to be some, you know, some 10th or 100th or 1,000th. Well, it turns out FEMA uses the 10th, and so that's what we use. So if you have 0.04 feet, that rounds down to 0.0 feet. If you have 0.05 feet, that rounds up to 0.01. 0.1, and that's just simply how we go about doing it, only because FEMA goes to the 10th of a foot. You don't submit to the 100th.
Okay. We actually have another question here. I'm not exactly sure. I'm going to go ahead and just ask it. I'm not exactly, maybe you'll know what is change in the flood elevation limit of 1.0 compared to natural conditions, in other words, before the highway existed, or to existing conditions, the current conditions, or current today?
Yeah, that gets a little bit more complicated. That's a very good question. That probably gets a little more complicated because and a little bit more that was going to take more discussion that probably we can do right here. So
Okay.
again, that person's welcome. That's a little bit more complicated question.
Sounds like maybe, yeah. So we'll, it sounds like we're getting a lot of people that might need to call you or actually contact you. They can actually contact you by getting a hold of, or actually going to the drainage section of the highway KYTC drainage site, and they can call there and ask for you and get you, correct?
Correct.
All right. So that's what we'll have people do. I don't have any written questions. Looks like I have a couple of people who have held their hands up. They may actually be able to speak. Let's see if we can. I got a Stephen Garland here who's holding up his hands. I'm going to turn off his mute and see if he can speak. Looks like it's not working. Oh, he actually took his hand down.
He took his hand down. Well.
Yeah, so apparently that was an accident. So nobody else is holding up their hand. And if there's no more questions, give maybe about another 30 seconds for anybody to ask questions on the question panel. Going once, going twice. Okay, well, Ron, I think that's what we got for today. I appreciate you coming in and talking to us. And again, if anybody has questions, you can contact Ron through the drainage section here in Highway Design. If you actually go online, you can look up KYTC Design Drainage and actually get a number to call, and somebody will get you to Ron over there to answer your questions for those questions that may or may not have been answered to the best of the limits that we have today over the internet. Ron, thanks again, man. I can't appreciate it. And again, I'd like to remind everybody, if they can, to hold off shutting down your webinars until you actually answer your surveys. Those help us out a bunch. It takes a little time for those surveys to pop up, so give it about a minute for those to pop up. And if you can, just go through those surveys. I'd appreciate it. Ron, thanks again, and we'll see y'all next time.